This video is part 3 on sequences for Algebra 1. So let's jump right into a problem. Let's review the dogs again. So when we were coming up with the dogs, what we were looking at were the number of dogs in each picture. So I'm going to make a table real quick. So we've done this table at least twice now in the last 2 videos. So for our first picture, we had 1 dog, then we had 3 dogs, we had 5 dogs, 7 dogs, and then we continued the pattern because our pattern here is +2. This is an arithmetic sequence, and if you remember, an arithmetic sequence is a sequence in which we're adding the same number every time to get from one term to the next. So since we're adding 2 every time for our dogs, it's arithmetic. So our next one is 9 and 11. And we came up with something called the explicit formula. And if you want to review what that is and how I got it, you can go watch part 2. But the video for this formula is 2n minus 1. So the explicit formula for the dogs is 2n minus 1. So what I'm going to do now is I'm actually going to graph this pattern and see what it looks like. So what I'm going to do is my figure is going to be the x value, and the number of dogs is going to be the y value. So let's see, for one picture, I have 1 dog, so the 0.11. For 2, I have 3 dogs. For 3, I have 5. 4, I have 7. 5, I have 9. And 6, I have 11. So I've graphed the pattern here, and I want to look to see, are there any patterns in the graphs? Let me change colors here so we can look for a pattern. So if I'm looking here, it looks like they're evenly spaced out. So I see these nice evenly spaced, but how much are they spaced? Well, I'm not going to go diagonally because I can't count diagonally without Pythagorean theorem. So I'm going to do over and up. So from the first to the second term, let's just start there. I go over 1, up 2. So I go over 1, up 2. For the next one, I go over 1, up 2. Okay, so the next one, I go over 1 and up 2. Over 1, up 2. Over 1, up 2. Over 1, up 2. And that pattern continues and continues. So if I want to find the next term, I could go over 1, up 2. So for picture 7, would I have 13 dogs? Yeah, I would. I would just add 2 and I keep going. And so if we notice the pattern, what pattern do you notice? We go over 1 and up 2. So if we notice this pattern, we can continue the sequence graphically. Now, what's significant about this? Well, our common difference, if you remember, common difference is the thing you are adding every single time is 2. And how many are we going up every time? We're going up 2 every time. Now you could be thinking, well, where does the 1 play into all of this? Great question. Well, on this side, we're going up by 2. For my figures, what are we going up by? We're going up by 1. That's why I'm going over 1 on the x and up 2 on the y. It's all here in the table. So we're going to use this pattern to actually find the common difference from some graphs. Now, before I get into some graphs, let's review a little bit specifics about sequences. So the big question is, what is the domain of a sequence? Well, if you remember, the domain of a sequence is the natural numbers. Now, as a refresher, domain is the input. Basically, what numbers are we plugging in? Well, we are plugging in positive counting numbers. And if you remember the question why, it's because we're not going to have a term 1.5. We're not going to look at our dogs and say how many dogs are in picture 1.5. That's weird. We have picture 2, we have picture 3, we have picture 4. And the way I always like to remember is that you can't finish a race in position 1.5. Either first, second, third, so on and so forth. So for sequences, we stick with positive counting numbers. So we're just going to plug in 1, 2, 3, 4, so on and so forth. So that's just a refresher of the domain. So let's look at another pattern and see what we see. So here I have some snowflakes. All right, so let's see how many snowflakes I have. 1, 2, 3, 4, 5, 6. So I have 6 snowflakes in the first one. I have 2, 5, 9 in the next one. And I have 3, 7, let's see, 7, 8, 9, 10, 11, 12 in the next one. So if I'm looking for the pattern here, what's happening? Well, I'm going up by 3. So my next one will be 15. My next one will be 18. And my next one will be 21. So I'm going to go ahead and graph this. So I've got 1, 6, 2, 9, 3, 12, 4, 15, 5, and 18, and 7, oh, sorry, 6, 21. There we go, 6, 21. So let's look for the pattern. Now for this one, the formula for this is f of n equals 3n plus 3. And if you want to work this out, you could plug it in the formula. If you want a refresher, the formula f of n equals d times n minus 1 plus f of 1. So you can plug that in, work it out, and get the formula here. But what I'm going to look for is I'm going to look for the pattern. So if I go here, how much am I going up and over? I'm going up 1 over 3. Going up 1, or sorry, over 1, up 3. Over 1, up 3. Over 1, up 3, over 1, up 3. And we see this pattern works for all of our points. Now, why is that the case? Because our common difference is 3. So I'm going to go over 1 to represent I'm counting my figures. So I'm going up 1 over here. And I'm going up 3 because I'm increasing by 3 snowflakes every single time. So let's use this pattern to go backwards. So here I've got a graph, and what I'm going to do is I'm going to write the explicit formula. So my goal in the very end is to have f of n equals something. Now remember, the two big things we need are the common difference and the first term. Those are the two big things we need. So the first term, we'll start finding that. So the first term is f of 1. So it's when our input value is 1. So if I look on my graph, here's where my input value is 1. So that means my first term is 7. Look right here, 7. Next, I need to find my common difference. So what's the pattern that I'm going by on this graph? Well, I'm going down 2 over 1. Down 2 over 1. I'm going down 2 over 1. And I'm going down 2 over 1. So if you remember, the over 1 is just because I'm increasing the figure number. So this would be figure 1, figure 2, figure 3. But the pattern I'm looking at here is this negative 2. So my common difference is a negative. And if you think about it, it makes sense that I'm adding a negative, so it's going down every time instead of going up. So I found my common difference. I found my first term. So I'm going to use the formula d times n minus 1 plus f of 1 to find my formula. So let's plug it in. So I've got, let's see, negative 2 parentheses n minus 1 plus 7. So I replaced all my parts. Then I'm going to simplify. So I'll distribute here. So I get f of n equals negative 2n plus 2 plus 7. And then I combine here to get negative 2n plus 9. And that's my formula. And if I want to check, I can plug in some numbers, make sure it works. Now I want to point something out. Notice here I have a 9. I want to start back at my first term for a second. If I were to go backwards and find, I'm going to put this in a little parentheses, to find our term 0. Now there is no such thing, but that's why it's in parentheses. If I were to follow the pattern backwards, meaning go over 1, up 2, what y value do I hit? I hit 9, which shows up in my formula. And remember, -2, the common difference, shows up here. Well, let's try another one and see if that holds. So here I have a pattern. So we want to find our common difference in our first term. So the first term is easy. We just look at the graph and we find our x value of 1. So we have 1. There's my first term, -3. Next, we find our common difference. So in other words, what's the pattern that's happening? Well, I'm going over 1, up 3, over 1, up 3. Then I'm going over 1, up 3, over 1, up 3, over 1, up 3. So you can probably guess by now that my common difference is 3. Remember, the 1 accounts for I'm increasing the figure number. So figure 4, figure 5, I'm adding 3 every single time. Now I'm going to go ahead and plug it into my formula. So f of n, d times n minus 1, plus f of 1. So let's see what we get. So my common difference is 3, and minus 1 minus 3. So let's go ahead and distribute. So I have f of n equals 3n minus 3 minus 3. And then combine my terms. So my formula here is f of n is 3n minus 6. Now, again, we know that the 3 comes from the fact that we're adding 3 every time in our sequence. We saw that in the pattern. But again, if I were to find this quote-unquote term 0, if I were to back it up 1, I will go down 3 over 1. Well, hey, there's -6 again, which shows up here. Useful. Let's do one more. This one's a little trickier. So for this one, we have to think a little bit for our common difference. We'll get to that in a second. Let's start by finding our first term. So our first term here is 1, because if I look at 1, my y value is 1. Now, here's the trick. Well, I'm missing a term. I don't have a term 2 here. So I'm going to have to think a little bit about how to get term 2. So I'm going to count this pattern. So I'm going to go over 2, up 1, 2, 3, 4, 5, 6. So I'm going up 6. Now in sequences, if you remember, we count with the positive counting numbers. We don't skip terms. So I need to figure out, where would my second term go? Well, we can think about this a little bit. If I'm adding 6 for 2 terms, well, I can find my common difference with some division. So I could figure out 6 divided by 2, and that means I'm adding 3 for every 1 term. So let's see if that works. So my common difference of 3, so I'm going to draw that in my pattern. So I'm going to go over 1 and up 1, 2, 3. And does that split the difference? Over 1, up 1, 2, 3. It does. So I'm just going to do a little comparison here. So instead of going up by 6 for every 2, I'm going to go up 3 for every 1. So I'm just doing a little simplifying. So let's continue that pattern. Over 1, up 1, 2, 3. Over 1, up 1, 2, 3. And it should come out nice and even. Connect all your dots perfectly. So there is my common difference here. So I had to do a little division to come up with my common difference, which in this case is 3. So now I'm going to plug it into my formula, plus f of 1. So we plug in 3. So 3 times n minus 1 plus my first term. So I'll distribute here. So f of n equals 3n minus 3 plus 1. There we go. And we combine our terms. So f of n equals 3n minus 2. So let's see if that elusive quote-unquote term 0 still works. Quote-unquote term 0. Technically doesn't exist, but get the idea. So if I go backwards, if I go down 1, 2, 3, hey, I hit -2 again. Well, that's awesome. So that concludes part 3 of our sequence series. In the next video, we're going to look at sequences where we're missing some more terms and look at a formula to help us get through the problems. Stay tuned.